friends, I'm back with another video. This time it's load balancing. So let us understand what load balancing is, how load balancers are a critical component in your application infrastructure. Okay, so just let's dive in. So imagine when you access your applications such as maybe your mobile banking applications. Let me just try to do some whiteboarding. Okay, so let's say this is your maybe a Swiggy application, Swiggy mobile app. Okay, once you access the Swiggy mobile app, uh, you are one customer who is accessing the app and trying to order some food. Okay, and as we know from my previous videos that there is a concept of front end and there is a concept of backend where you have your data center, you have your backend servers which are actually accepting and processing your request, right? That means it seems that you are doing a lot of things over here on the mobile app, but the actual processing is happening over here. So when you connect to your app, you try to do some food booking, actually you are accessing this server at the backend and doing the processing, right? Now you are one single customer, but imagine during peak hours, maybe weekends or in the evenings on weekends, there are so many customers, in fact customers in uh, thousands or maybe millions, right, accessing this backend application server. Now this backend application server has a limited capacity or a finite capacity, I should say, where it has some amount of CPU and RAM which can actually process all these requests which are coming in, right? Okay, that means it has a limit. Now what will happen if these all these customers, these millions of requests, you know, connect to this server simultaneously? There is a high possibility and a chance, in fact not a possibility, it's a fact that it will utilize whatever CPU and RAM it has, and in fact it can actually go into a state of maybe hung or non-processing state, or maybe in technical terms normally what happens is a state called as out of memory, OOM. That means there is no enough memory to process this request, right? So that means this server, if there is a single server which is handling all these Swiggy requests from different customers, what is going to happen is that this server is going to crash, right? Server is going to crash, and what is going to happen that the services will not be available and there will be a downtime. All these customers can get frustrated. Okay, so how to solve this issue and how this issue is mitigated in terms of having load balances in place? Before that, I'll try to give you one more analogy. Maybe this time, the best analogies are basically restaurants and kitchens, which we can use. Let's say you are ordering some food, okay, uh, to maybe an outlet, a restaurant, right? And there is a cook who's preparing the food. Okay, you gave the order, okay, to this cook, and he took your order, he started preparing the food. At the same time another customer came, he started preparing the food. Another customer came, right? Now as a human being he has limitations, like okay, he can only prepare 3 dishes at a given point of time simultaneously, right? But if there are more customers coming in who are actually trying to place requests, what is going to happen is that this cook will not be able to cook more food, okay, because he has limitations. He has his own level of capacity which can be used, right? That means after these three may have to wait. That means additional time will be required. Once these 3 dishes are over, then only he can start the fourth, fifth dish, right? Okay, so to tackle this problem, what happens is that normally you may first of all have multiple cooks, okay, right? Secondly, okay, you may have some kind of uh, a person in between who actually takes your order and then load balances it between the different cooks. So for example, let me just rub this part. Sure. So that means this person in between. This is a important person where all your requests are going to this person. Okay, and this person is actually load balancing. Oh, sorry, what happened? This person is actually load balancing all the requests to the different cooks. So this is how a load balancer will actually work. So if you take this analogy in terms of servers and a LB, your all your requests which are hitting from your, let's say, mobile apps, okay, are going to a load balancer, and this load balancer is actually load balancing all the requests to different servers. Okay, now there are specific methods how this load balancing happens, but before that I would just want to highlight a few concepts so that you internalize the main advantages of having a load balancer. Okay, so first of all, if you have multiple servers servicing the request, if one of the servers goes down also, this load balancer is intelligent enough to not send the request to this dead server, because if those requests, or maybe in this case around 30% request goes to this server, what is going to happen, those requests will not be served because this server is dead. That means the load balancer is actually probing all servers every second, whether they are available or not, whether they are working or not. Okay, so this is called as probing, where your load balancer is always actually checking the status of these servers. Maybe basically it actually probes, or I should say makes a port based connection. That means there is a port being serviced, or a port available on each of the servers on which a service is listening and serving the request. So it actually connects to that port every, let's say, 10 seconds as per your configuration, maybe 10 seconds, 20 seconds, 1 minute, to check whether that service is on or not. If that service is not available, then definitely that server will actually be moved out. I mean, moved out in the sense, all these servers at the back end in terms of load balancer configuration is called as a pool. Okay, and this side of the IP on which all the requests are coming are called as a VIP, virtual IP. That means this virtual IP is basically mapped to this pool of servers. Okay, so basically in this pool, if one server goes down, all the requests will be going to the two other servers, so that all the customers who are connecting, all the application front end applications who are connecting will not be impacted, and their request will be served. That is the concept of load balancing, and how VIPs are used, and how probing is done. That is how it happens. Now let's look at what are the rules of load balancer. That means what are the algorithms being used. So for the algorithms, basically what happens is that if you have, let's say, three requests coming in via an LB to, let's say, for simplicity I'll take only two servers at the back end. Okay, so this LB is actually load balancing between these two servers. How it is doing is that there are multiple algorithms to do that. One is, or maybe first one is round robin. That means it will send the first request to this server, automatically second request to this server, then the third request will go to the first server. If there is a fourth server, if that request comes, that fourth request will go to this server, then fifth, sixth, seven, eight. So this is the concept of round robin. Okay, second is your least connections. Least connections means, now it many cases it can happen that uh, this this connection which is gone to the first server, it is taking some time to process. Maybe the user did not click, or user is not that fast. Let's say, imagine if he's running a journey of uh, ticket booking, and he's very slow in selecting the seats, and selecting the theater location and everything. So that means his connection is over here, and in the meantime the request which came from here already got served and completed. So what will happen if many such slow users are actually connected to this server, the request will pile up over here. Okay, and in that case, if we do the round robin, then automatically the request served by this server will be high and this server will be low. So in that case, in a more intelligent way, the load balancer can understand how many connections it has sent and how many connections are still live on this server. Basis that it can understand that this server is automatically having high number of connections, so let me send the new connections directly to this low server, unless and until it also has the same number of connections available to serve. So that is the concept of least connections. Uh, Third is latency and response. This is in a LAN environment, probably this may not be used so much, but the LB can actually ping or maybe probe that the in how much time this server is giving a response. Let's say this server is giving a response in 100 milliseconds, this server is giving a response in let's say 300 milliseconds. So this can also be a metric or a parameter which can actually tell the load balancer that this server is a bit busy because it is giving the response in 300 milliseconds. So all the new requests will be going to this server. Okay, that is the concept of latency based load balancer. Okay, now all these algorithms can be used and are normally available in all the load balancers nowadays. Okay, but it depends upon you. Maybe if you are an SME or an architect configuring and implementing this load balancer design, you have to design this basis your traffic pattern. Okay, how is your traffic, how is your journey formulated, how the journey traverses, whether round robin will be the best, these connections will be the best, or latency based, that you need to decide. For example, if this is something like a GSLB. Okay, GSLB is a concept probably we can uh, you know learn in future videos, where a global server load balancer which actually load balances over the internet. It uses latency based uh, load balancing, where it there are so many servers on the internet where it is connecting, and it can decide which server to send basis the latency of the servers. Okay, so it is important that you understand that it is a traffic pattern which is which needs to be kept in mind for deciding upon the algorithm. Okay, now the last part which I wanted to tell you is that, or explain you, is that the types of load balancing. Ideally load balancers are nowadays available in both formats, which is your hardware based LB and software based LB. Okay, hardware based LBs are more robust and can process more requests at any given point of time. Software based LBs are obviously not so robust and not so high performing, because the software based LP is basically you are actually having a VM on which you are installing LB software and then running. So these are the two basic models available for your load balancer to be placed. Uh, if we talk about types of load balancers, types of load balancing, there are two. One is layer 4 load balancing. That means when I told you that this is an LB, there are requests coming in. There is a VIP virtual IP on which this request will come, and on this VIP, okay, there will be a specific port. Let's say 443. If that request comes onto this specific Ports are basically a OSI layer 4 layer. Okay, layer 4 layer. Okay, so uh, this type of load balancing where the requests are being identified basis the port number and then routed to specific servers, of course on specific port number, maybe 443 only in this case. That kind of load balancing is called as layer 4 load balancing. It is pretty straightforward. That means the LB does not have to do too much of intelligent routing basis the VIP. It just checks the port number that the request is coming on this, let's say VIP, a combination of this VIP and port number, and it routes the request to a particular pool of servers. This is simple layer 4 load balancing. Second type of load balancing is layer 7 load balancing, where what is being done is that instead of just looking at the port number, what the LB can do is that it can actually read the request, right? For example, when you say layer 7, that means whatever is there in the request. Okay, maybe if we take an example of an API, so API can be www.abc.com slash maybe slash, let's say, get balance. Okay, if this is an API, the LB can actually read this get balance, and it can actually route requests to servers which are supporting balance. Maybe if the same URL www.abc.com has maybe slash login, okay, slash login, then in that case that slash login request will be routed to some other servers. Okay, this is one example where you can say context based routing is being done by a L7 load balancer. And more than this is that it can also read the request headers. That means in the API, if it's a JSON request and in the request header there is some identifier written that okay, the, let's say, identifier as app, let's say app, let's say app for uh, app UK. Okay, in the JSON request, other things will be same, maybe something like a customer ID, maybe name, email, right? These can be part of the request, but just looking at this app UK, the load balancer can actually send the request to UK servers at the backend. Same way in this identifier, if it is written app US, then the load balancer can actually send it to US servers. Okay, so that is the concept of layer 7 load balancer, where it is more intelligent. It can actually understand that what is happening at the application level, what is there in the application request, and based on that it can do the routing. That is the difference between layer 4 and layer 7 load balancing. So I hope I was able to articulate and give you some knowledge about load balancing, how it works, what are the algorithms, layer 4, layer 7 load balancing, and how it is a critical component, because when it is about millions of customers accessing simultaneously at the same time, then it is very important that you have a load balancer in place. Okay, thank you, thanks a lot for watching, and if you feel that this video is informative and you have benefited from it, then definitely do subscribe and give a like to this video. Thank you, thanks again, bye bye.